So this video we are going to discuss the lithography process, or sometimes referred as photolithography. Uh, Basic idea of lithography is that you can transfer the patterns of geometric shape in a mask onto the thin layer, onto the uh, surface of the semiconductor wafer. So geometric shapes in a mask to a thin layer of radiation sensitive material, sometimes called photoresist, covering the surface of a semiconductor wafer. So first, to create a pattern with a dimension established by the directed by the circuit design, place the pattern correctly, aligned with proper alignment with respect to the crystal orientation and other existing pattern. The lithography process, this starts with placing the photoresist layer over the wafer. Now this patterning is achieved by the process called photolithography. So by the name you know, the photo is light, lithos is the stone, and graph means the pattern or picture. This literally means the carving pictures on the stone using light. That's what known as the photolithography. Just to define the areas of interest, primary method is for defining the areas of interest. That is where we want the material to be present or absent. So these areas of interest is getting patterned through this photolithography process. So first step of this is to be coated. The wafer is to be coated with the photoresist and subjected to the selective illumination through this mask. That is another photo mask. Okay, so this photoresist photolithography is it consists of, it must be a photo mask or simple mask, and some photoresist must be covering the wafer. So after the initial patterning of the photoresist, the barrier layers such as polycrystalline silicon, silicon oxide or silicon nitride can be used to physical mask on the chip, can be used as the physical mask. This distinction will become more apparent as the discussion is progressed. So as you can see, a pure silicon wafer have a oxidation process. Already we have not discussed how this oxidation process can be completed. That we will discuss later. So this layer of silicon oxide can be formed on the silicon wafer, top of the silicon wafer, oxidation. Then on that we are giving a photoresist coating. Then using some mask to define the active areas of the pattern making, and then giving the illumination using some ultraviolet ray, we can define the pattern onto the surface. So for example, these are the position where we want to open these three positions. We want to open the surface of the wafer. So we are giving the photoresist entirely, and then using this mask we are defining these three regions. After illuminating with the UV ray, these portions will be kept intact on the surface, and remaining portions can be removed using some PR developer or etching process. Etching process also we have not discussed, so we will be discussing on that in some other videos. So then if the photoresist of the desired location is somewhat different than the covered location, so this portion can be removed, so that we are getting the opening of the silicon surface at particular location. These openings are now can be given for the diffusion or ion implantation or chemical vapor deposition, different process in order to grow the uh, different material on the silicon, pure silicon. So this is what the process of photolithography. So starting from the pure silicon wafer, then silicon oxide layer, then the photoresist material, then using the photomask or mask, generating the pattern with the help of UV rays. After etching, the removal of the photoresist material from the selective places, and now the selective windows has been created where exactly the doping process or some impurities introduction can be possible. This is in short the photolithography. So the same process is to detailing, either the spray coating or spin coating. We can use the photoresist material onto the surface of the wafer. So photoresist is sprayed over the wafer using the photoresist spraying machine, or in this process PR is put on the wafer and then at a high speed, if it's rotated, then the photoresist material can be sprayed and get covered on the silicon wafers. There are the photoresist material is made of organic component material, maybe of two types: positive photoresist layer and the negative photoresist layer. So two kind of, due to the chemical properties of this organic material, it can be of onto the, when you expose the light onto the photoresist material, it can be of two types: positive photoresist material and the negative photoresist material. In case of positive photoresist material, the resist is exposed with UV light wherever the underlying material is to be removed. So the mask is given such that this photoresist material is exposed to the UV light using the help of the mask whenever the underlying material is to be removed. That means this photoresist material, after getting the UV light, it becomes softer, okay, and which can be removed by the developer solution. So this resist, the exposure to the UV light changes the chemical structure of the resist so that it becomes more soluble to the developer. And where the non-exposed areas, that remains intact on the surface. Exposed resist is then washed away by the developer solution, leaving opening to the bare underlying material. In case of negative photoresist, this exactly happens opposite. Resist exposed to the UV light, it causes negative resist to become polymerized, and that won't be dissolved. Very difficult to dissolve with the solution. The remaining portion where the UV light was not exposed through the mask, it remains developer solution removes the only unexposed portion. So mask used for negative photoresist, therefore it's sometimes known as the photographic negative of the pattern to be transferred. Mask alignment is very important. One of the most important steps on the photolithography process is mask alignment. A mask, a photo mask, is a kind of glass plate with a pattern emulsion of metal film on one side. Other side, it is the image of the pattern. The pattern can be transferred onto the wafer surface. Each mask after the first one must be aligned to the previous pattern. So pattern is actually several stack of pattern is required. Once a mask has been accurately aligned with the pattern on the wafer surface, the photoresist is exposed to the pattern on the mask with a high intensity ultraviolet light. There are three primary exposure methods. One is contact, on proximity, or projection. These are the different exposure method. Okay, this is the contact. So on the material, the mask is given on contact using the focusing arrangement optical system. The light source is the UV source is exposed to the UV source is now coming onto the silicon wafer. Here there might be gap in between the mask and the actual silicon wafer. And the projection method, there is some focusing arrangement where the actual silicon wafer plate and the mask, they are having some optical arrangement so that they get more precise pattern can be transferred. Okay, so contact printing, proximity printing, or the projection printing, they are having their own advantage and disadvantage and their cost.